So this again, classify these salts as acidic, basic, or neutral. So I have again NH4, ClO4. I have k3po4, and then I have Na2S, and then I have KCl, and the LiNO3. Okay, so I know that KCl here is neutral because I solved for that in the previous solution here. So let me just write down that guy here. So I have HCl plus KOH will give me KCl plus H2O. So therefore, this guy here is neutral, right? So I know that this guy here, KCl, has to be neutral. And let's see, what else do I have here? Okay, so let me solve for the first guy here. So again, I'm going to dissociate all these guys here into its ions, right? So again, I have here, this is going to dissociate into, I have NH4 plus again, and then I have plus ClO4 minus here. And then this guy here, I'm just going to dissociate into, I have K plus PO4 3 minus here. And I'm going to need a 3 here to balance this chemical equation. This here I have Na plus S2 minus. Again, this here is 2. And finally, it's LiNO3, right? I don't know why they have LiClO4 then, actually. But I'm going to go with the question here and say that this here is Li plus NO3 minus here. So I've dissociated this in ions. So let's focus in on what that means here. So I'm going to write this in blue. Oh. So again, I have NH4 plus ClO4 minus, right? So again, I can do the exact same thing, and it's going to give me, again, I know that ammonium here reacts in water, right? So I can basically do the exact same thing as I did with the previous question. This is going to react to form. Again, I have NH3 plus H3O plus. And this here will give me my acetic acid, so therefore this guy is correct. You can also write the ClO minus guy here. Plus H2O. This will give you a basic reaction here, but you don't really have to worry about the negative kind of the negative anion in this case here. So I'm gonna erase this here. So just know that ammonium here reacts in water. Second guy here, I have 3K plus and I have PO4 3 minus. K plus here is our spectator ion in this case, so I don't have to worry about K plus, but I care about this PO4 minus, right? So I have PO4 3 minus. Going to react with water to form, or actually I should have done this in blue. PO4 3 minus plus H2O will get me. Oh. And I have here, this would be a phosphoric acid, right? So I have HPO4, and this will be 2 minus plus, I have OH minus here. And this here would be a basic, right? Because again, I'm making a hydroxide here, so this guy here has to be basic. So number 1 here was acidic, like we said before. This guy here is basic because we're making, again, I made HO3 plus and I made OH minus here. Sweet, so that's good. Let's look at number 3 here. I have 2 Na and S2 minus. So in this case here, I'm going to, again, the Na here is our spectator ion, so don't worry about that. So I care about this S2 minus, right? So S2 minus, so that's a plus H2O. Again, this hydrogen is going to donate, I'm going to donate a hydrogen to S, right? To make this SH minus, HS minus plus OH minus. Again, I have the OH minus here as well, which means this guy here is going to be basic, right? I already know this was neutral. And finally, LiNO3. If you look at NO3 here, this guy here is actually the conjugate acid of this guy here, or the conjugate or let me write this out for you actually before I explain this. So I have NO3 minus plus H2O. This is actually not going to be in equilibrium. It's actually going to go fully to HNO3 I have HNO3 here. So in this case, and OH minus. And in this case, you might be fooled by this because I have OH minus here. Oh, it's basic. But you have to realize that this nitric acid here is not a weak acid. This here is a strong acid. So in this case here, this OH minus is basically negligible, and you can say that this is a product of, again, a strong acid and a strong base reaction here. So you can think of this as HNO3 as my strong acid plus lithium hydroxide would get me lithium nitrate plus water. In both of these cases here, I have this here is a strong acid, this here is a strong base. What do I do? This here is a strong base, which means this salt has to be a neutral salt here. So therefore, this guy here is neutral. So in this case here, I have acidic, basic, neutral, neutral. And so I have acidic here, which is good, basic with k3po4 and Na2S, which is good, KCl, which is neutral, LiNO3, not ClO4 here, which is neutral as well. If this was actually ClO4 here, this guy would actually change this property here. So mistype solution is incorrect due to a mistype or something like that. Neutral should have had KCl and LiNO3. And then no analysis given as well. And I don't know if I want to copy all these guys here down, but I guess I'll do it just to prove. Maybe I'll do a sample analysis for first two compounds here. So I have NH4, ClO4, dissociates into NH4 plus ClO4 minus, which in water reacts to get some NH4 plus H2O, give me NH3 plus H3O plus. The existence of hydronium ion means that the salt is slightly acidic. k3po4 dissociates into 3K plus PO4 3 minus, which in water reacts to get PO4 3 minus plus H2O, reacts to form of HPO4 2 minus plus OH. Plus OH minus here. Or I guess I could get H3PO I guess no, because this here, yeah, it's just simply HPO4 2 minus here and OH minus the hydroxide, or I'll say the existence here. The existence of hydroxide ion means that the salt is slightly acidic. And then I guess I'll do it for the first. I'll do it for 3 compounds, one acid, one base, and one neutral. LiNO3 is a product of HNO3, nitric acid, which is a strong acid, and LiOH, lithium hydroxide, which is a strong base. Say in a strong acid, strong base reaction, the salt produced is neutral. So this solution is correct. I say solution is incorrect due to this mistype here, and I also included my sample analysis for the 3 compounds here.